So name of the reading, Introduction to Multifactor Models. Now the premise of this reading is to get ourselves acquainted with the usage of multifactor. I want you to pay special attention to this word introduction, which means the level of depth which is expected at this topic is relatively a very basic level. So what is a multifactor model? Or maybe a closer example is what we did at CFA Level 1 with a model called CAPM. What CAPM told us, how much return you should expect on a particular stock is a function of RFR plus what is the beta into equity risk premium. So when we use CAPM, we defined that there is only one risk exposure. That risk exposure is what is the beta of the market and what is the RM minus RF. That means what is the equity risk premium. As against this, what multifactor says is that instead of having only one exposure, let the analyst have or decide which all risk factors or which all risk elements the stock is exposed to. So one classic example that they've given, or one type of multifactor model, is called APT, Arbitrage Pricing Theory. What this model will do is it will give you a similar equation. It will say cost of equity is equal to RFR plus. But then it will ask you what are the risk elements to which the stock is exposed. Maybe the stock is small cap, so you'll have a sensitivity which is beta into the risk premium for stock being the small cap. Plus maybe the stock is high price to earning, so you'll have a sensitivity towards the price earning ratio into the risk premium we should earn for that. Plus the stock is illiquid, so you will have a beta plus the risk premium for illiquidity. So as an analyst, you get to define what are the appropriate risk metrics, what should be the risk premium, and what should be the factor sensitivity, which is essentially your beta. Are we clear with this? So first, learning outcome. The learning outcome is about arbitrage pricing theory and the underlying assumptions. So first point of discussion is arbitrage pricing theory is being proposed as a alternative to CAPM. Right? So instead of using CAPM, as an analyst you get more bandwidth to decide risk elements. Second, it says it is a linear model. So which means there would be a linear relationship between the risk elements and the expected returns. But one of the disadvantages which is quoted in this model is that it does not identify any of the risk factors. So let us say we want to build a APT model for one of the listed companies. So APT model will give us the specifications on how to build factor sensitivity, how to get risk premium, but it will not help us identify which risk premium should be used for that stock. Is that making sense? Some of the assumptions here. Number one, unsystematic risk can be diversified away. What is unsystematic? A stock specific risk. So it says that unsystematic risk is diversified away, and since it can be diversified, an investor should not be compensated for taking unsystematic risk. Second, it says returns can be generated using a factor model. So it essentially says that APT should work. That means return is a function of how much risk you have taken on multiple fronts. So returns can be generated using factor model. And number third, that if we enter into a scenario where the returns are being offered are more than the risk, returns are offered which are more than what is appropriate for that level of risk, or less than what is appropriate for that level of risk, then there would be an immediate arbitrage which will eliminate all future arbitrage opportunities. Similar to what we've seen in a lot of other arbitrage discussions. So let us build an example. So this could be our first example of arbitrage pricing theory. Let us say we are building a model similar to this. So we have factor sensitivity and we have risk premium. Okay, right now I'm not defining any of the factors, so let me just call this as factor 1 and factor 2. Let us say sensitivity is being defined as 0.7 and 0.52. The risk premium for this particular factor is given to us as 6%, and risk premium for this factor is given to us as 8%. On top of that, we are also being provided with RFR of, let us say, 4%. So we will have a data of this nature, and then using the arbitrage pricing theory model, we will be required to figure out what is the expected return. So how will we do that? We will use following formula. We will say RFR, which is the intercept, plus beta of factor 1 into risk premium of factor 1 plus beta of factor 2 into risk premium of factor 2 plus error term. So your RFR is being quoted as 4%, beta is being given as 0.7, first risk premium is 6, then 0.52, second risk premium is 8. How much is this? 12.36. So 12.36% is your expected return. A simple multiple regression model. Are we clear on this one? There is no limit on factor sensitivity. There is no limit on risk premium. There is no limit on number of factor sensitivities you would want to have in your equation. Okay. Then one single line. Unlike CAPM, APT does not require one of the factors to be equity risk premium or market risk premium. So there is no compulsion that you have to have equity risk premium as one of the variables. So your factor exposure could be exposure towards interest rate, or it could be exposures towards GDP, or it could be exposure towards, let us say, Forex, or it could be exposure towards price earning ratio, price to book. So it could be an economic variable, it could be a fundamental variable, it could be anything. It is not necessary to have market risk premium or equity risk premium as one of the variables. Are we good with this? Okay. For every risk premium, there would be beta. So for every risk, you need a factor sensitivity, which is beta, and the risk premium. Should we go ahead? Beta with respect to that. For example, in the current scenario, let us say we are looking at two stocks. Let us say L&T as one stock, and let us say Hindustan Unilever as another stock. So L&T is a listed company in infrastructure space in India, and HUL is in FMCG space. Now we are trying to build a multi-factor model. So we try to figure out what are the risk sensitivities. So let us say one of the risk sensitivity is GDP growth rate, or in fact even better, one of the risk sensitivity is government spending. So then what we would say is that L&T as a stock should have a higher risk sensitivity on government spending, whereas HUL as a stock will have a lower risk sensitivity. So which means that beta value is a function of the characteristics of the stock. Are you following this? However, the risk premium for both the stocks would be same. So what we will say is that risk premium for government spending is one particular number, let us say 5%. We will discuss later on how this 5% is derived. But we will say in case of L&T, the beta value could be 1.2, but in case of HUL, it might be just 0.2. And how do you interpret this? That if government spending is more, if government spending is more, then in a way you have higher advantage in L&T compared to Hindustan Unilever. Is that making sense? Okay. So you would get a few questions based on arbitrage opportunity. So just give heading in the notes. Arbitrage opportunity based on APT. arbitrage opportunity based on APT. In fact, that's how it derives its name. Arbitrage opportunity based on APT. Okay, so you would be given names of 3 stocks. Let me call them as X, Y, and Z. Then you would be given the factor sensitivity of each of the stock. So let me call them as factor beta. So let us say this is 2, this is 1, and this is 1.5. And then you would be provided with the expected return or return premium or risk premium for these stocks. So for X, let us say it is given as 20%. For Y, it is given as 12%. And for Z, it is given as 15%. And based on this data, you would be asked a question that can you identify any arbitrage opportunity? Can you identify any arbitrage opportunity? Okay, so how do you think of this? So you first identify which one of these. In fact, instead of 15, let me keep this as 14. So even at 15, it will do the job, but let's keep it as 14. Then you identify which one of these is the least efficient stock. So the least efficient here is stock Z, because for 2 we are getting 20, for 1 we are getting 12, but in this case for 1 we are just getting about 9. Then once we know, is it fine, Ajit? Least efficient is return divided by risk. So this will get you 10, this will get you 12, and this will get you 9. Therefore this is least efficient. Then build a portfolio of X and Y in such a way that the beta of that portfolio should be 1.5. And do you agree that beta of a portfolio is simply the weighted average of constituent securities? Correct? So let me assume weight here to be W. I'm assuming weight to be W. Then weight for Y is going to be 1 minus W. So we will have W into 2 plus 1 minus W into 1, and then this answer, we want this to be 1.5. That means we are building a portfolio of X and Y in such a way that the portfolio should have a beta of 1.5. Are you following what I'm trying to say? Now I'll give you an easier technique to handle these questions. So it's a small technique that we generally do in GMAT type of exams. So plot 2 here, plot 1 here, and we want that solution to be how much? 1.5. So take the difference between 1 and 1.5, which is 0.5, and take the difference between 2 and 1.5, 0.5, and the total of these is 1. So 0.5 is 50% of 1, 0.5 is 50% of 1. So your weight 1 and weight 2 should be 50-50%. So here 50% into 2 plus 50% into 1. So we will get a portfolio beta of 1.5. Agree? Now we have been able to construct a portfolio which has the same risk exposure as portfolio Z, but let's see how much return will we get. So again, a weighted average, 50% into 20 plus 50% into 12. So we will get 16. Whereas Z gives you how much? 14. So what is the arbitrage strategy? Arbitrage strategy would be to take a long position on X and Y portfolio, to take a short position on Z. Then you are eliminating that beta exposure, because beta exposure both the cases is 1.5, and then you would get to earn an arbitrage return of 2%. Assuming that you finished writing now, let's do one more. So three stocks, A, B, C, factor beta 5, 7 and 3, and the expected returns 36, 61, no, 36, 40, 77. Try to find arbitrage opportunities. Long B and C, short. Alright, let's do it together. Ajit, please see this carefully. Step number 1, find out return per unit of risk. So 40 divided by 5, 8. 77 divided by 7, 11. And 36 divided by 3, 12. Then which one is lowest? 8. So then we would take a short position here, and then we will take a long position on these ones, which is B and C. Now what we need to do is construct a portfolio of B and C in such a way that weighted average of 7 and 3 should come out to be 5. So we will assume that weight in B is W. So then weight in C would be 1 minus W. So the weighted average would be plus 1 minus W into 3, and this needs to be 5. Now if you want to do it, you can also solve for this equation, or you can use a faster technique. So start with 7 and 3, put 5 here, so the difference is 2, then proportion of 2 to the total of 4, so 50-50%. That means 50% into 7 plus 50% into 3, and that would get us 5. And once you know the weights are 50-50%, then find out expected return. Expected return would be 50% into 77, 50% into 36, so that's 56.5. So if you have a long position on this, we will get to earn 56.5. If you have a short position, then we will lose 40, and therefore your net return is 16.5%. And as far as betas is concerned, this will have a beta of 5, this has a beta of 5. So you would eliminate beta exposure, and therefore it would be considered as an arbitrage return. This is again same learning outcome where they will give you some data and you will have to find out the expected return. So there are two types of numericals we can see. Let's do the first one here. You've already done this. Let us say your beta exposure for factor 1 and factor 2 is 0.7 and 1.3. Risk premium 5 and 10. RFR 6. Calculate expected return. Do it quickly. How much, Sumit? 10. Then 10.80 होगा. This is 3.5. That's 1.3 plus 6. That will be. We got this wrong. That's 13 plus, so that's 16.5, 22.5. 22.5. Are we together on this? So just this into this plus 6. Should we go ahead? Okay, there is one more type of question. Are you okay with the first one? This one is particularly interesting. So we have two stocks, stock X and stock Y. Expected return of stock X is 10% and stock Y is 13%. Then the beta value or factor beta for a particular risk exposure was 1 and this is 1.25. So what you have to calculate is find out what is the RFR and find out what should be the risk premium. Expected return is the what you expect to earn out of that stock. That means in the previous question I was giving you RFR, I was giving you risk premiums and you were calculating expected returns. Now we have expected returns, calculate RFR and risk premiums. Alright, let's do it together. See, it's not so difficult. Plus I have a technique as well. So expected return should be RFR plus whatever is the beta into the risk premium. Now for the first stock it is 10%. We don't know RFR, so let me keep it as RFR. Beta is 1 and therefore it is risk premium. So that is the equation. Now what we can say is RFR is equal to 10% minus risk premium. Agree with this? Now let us build the equation for the second one. So second one would be 13% is equal to, now instead of RFR I am plotting in this value, 10% minus the risk premium, so that's your RFR, plus 1.25 into the risk premium. So that would essentially make this as 3% plus risk premium is 1.25 RP, so that is 0.25 RP is 3%, so your RP is 4 times, so that is 12%. And if your RP is 12%, then your RFR in this case unfortunately turns out to be minus 2%. Easy. Now while giving the question I got an idea, I experimented to see if it works. I mean an idea to solve this quickly. So what you do now is, have you written the answer? So what you do now, say second 7. Second 7. Keep your x1 as 1 and y1 as 10. x1 as 1, y1 is 10. Then keep your x2 as 1.25 and y2 as 13. And then say second 8 and search for A directly, A. So it will give you minus 2. And once you have RFR, then you can just easily find out what is the risk premium. Right? The reason why it's working is because if you think logically your expected return, the equation is RFR plus beta into the risk premium. So in a way, expected return is a y-axis variable, risk premium is a x-axis variable, and beta is the x-axis variable and beta is driving it. So if you plot that into the equation, it will automatically give you the intercept, which is RFR. Are we good here? Do you want to do one more? Have you written the solution? Okay. Risk premium for the same beta would be same. So it will not be different. If you are comparing the same betas, then the risk premium for each of the beta is same. What is different is the beta values. So again, expected return. So two stocks, J and K. Just coming up with random numbers, 17 and 25%. Then beta values. This is 0.9 and this is 1.3. So find out RFR and risk premium. Is it again minus? Let's change this beta value to 1.7. Hopefully now it won't be minus. So now RFR is 8% and risk premium is 10%. It works. 10 उसमें नहीं आएगा. 10 आपको खुद सॉल्व करना पड़ेगा. RFR you'd get directly. Once you get RFR, you can easily get risk premium. Do you want me to help you with the calculations? Huh? Calci approach. Second 7. Once you're in second 7, then say second clear work. Then x1 should be 0.9. y1 would be 17. y1 would be 17. x2 would be 1.7. y2 would be 25. Second 8, and then search for A, which is the intercept, which should be RFR. So once you have RFR, then we can use any of the equations. So expected return is equal to RFR plus beta into risk premium. Expected return is 17. We know that RFR is now 8. We know that beta is 0.9 into risk premium. So which means 9 is equal to 0.9 risk premium, which means risk premium should be